Hi, this is the Chess Efficiency Simulator project presented by Katie, Meg, and Logan. In this video, we will walk you through how to use our chess efficiency simulator and the results we got by using it.
So the goal of our project was to determine which chess pieces are the most valuable and that the ones you should protect the most because they are the most efficient in their movement across the board. And that's basically it.
So the first interaction that we have with our program is through this web server. So a user can choose where they want their ending piece to stop. So if you hover over the spots on the board, the piece you're on top of will change colors. So if you say, I want to end here, it'll tell you your X position and your Y position. And then you can choose which algorithm to use. So in this case, we'll use Dijkstra's, and it'll tell you that it chose that. The piece, we'll pick a knight. The cost comes down to, do you want to check how many moves the piece has to make to get to that spot, or how many tiles it has to go over. So we'll do moves. And then if we were to hit generate movement now, you'll get an error saying that you didn't enter max cost. So we'll enter the max cost as 7, and then we'll generate the piece. So now it'll go back and tell you everything. So your starting point is 0, your ending point for X is 5, same for Y, ending is 3, double check your piece and your max cost, and then that your algorithm is Dijkstra's. And if we go back and look at the terminal, you can see that it has displayed out that the total cost for that move with the knight is 10, and then all the steps that were made by the knight to get to from 00 to 77.
So from the command line, you can test different inputs by running the main program. And so now you enter your starting location. So for example, 0, 0, your ending location, let's just say 7, 7 on the other side of the board. Then we can say, let's do it with the bishop. And then let's run it with a cost of tiles. And then finally, let's just say, let's use Dijkstra's. And then if we press enter, it'll run the algorithm. And just say with a bishop, we can just do it in one move. And yeah, it's a total cost of 12 because that's how many tiles it had to cross.
So now, if we run make test, we will show that we made a series of test input files for the bishop moves. We tested various different starting locations and ending locations, and we even did an example of an impossible move, and that output gave us that it was impossible to make that move. And we did also a variety of tests similarly with the rook and with the knight piece.
And then we also tested for time, as well, as you can see below, to make sure that our algorithms didn't take too long.
So now let's cover the benchmarking. So we made a simple Python script to automatically benchmark our results. So as you can see, it tests both the elapsed time and the memory usage for the different input files. And from this data, we determined that the knight is in fact the most efficient piece in terms of both time and memory.
We also, from the results of the different testing with cost and being a move or a tile, we also found that knights are most effective when it comes to both different types of costs. So from the results of this project in general, we discovered that the knight, other than the king and the queen, is the most important chess piece. Thank you.